All right, so we are going to look into solving equations that have fractions in them. So let's look at a review one really quick. Notice this says x divided by 2 equals 11, and they want us to solve it. If you remember, to solve this, I think about first, what's my variable? Well, my variable is x, and I want to get it by itself. What's being done to the variable? The variable is being divided by 2, and I need to move that 2 away from the x. There's no addition or subtraction to do first, so I'm going to move the 2. Since it's dividing, the opposite of division is multiplication. I'm going to move it by multiplying by 2 on both sides. Remember, what you do to one side, you do to the other. The 2's cancel on this side, leaving me with just the x that's up top. And 11 times 2 is 22. So remember, that's how we solve the problem. But that's not really the point that I wanted to make here. The point I wanted to make was comparing it with this problem. So let's look at the two equations and consider the differences. Well, there's still an x up top, there's still a 2 in the bottom, and there's still an 11 on the right hand by itself. However, in this problem, I also have a 4 and a 1. So if you notice, the only thing in the bottom is a 2, but in the top there's more than one operation going on, and it's inside the fraction. Now, on all the other problems, when there was addition or subtraction, I told you you've got to move the addition or subtraction first. But now looking back, if it had been like this, notice the addition is to the right, or even if it had been like this, the addition is to the left. The addition is not actually a part of the fraction. So that's the main difference between what we have done and the way that these equations are set up. So when the addition or subtraction or multiplication is actually a part of the fraction, you need to get rid of that fraction to begin with by multiplying by the denominator. So essentially, since this is a part of the fraction, I can't subtract 1 from both sides because it's stuck up top. I got to get rid of the fraction first. So I get rid of the fraction, oops, by multiplying by 2, just like we did to the problem over here. So now when I multiply by 2, the 2's cancel here. I bring down everything that's left up top. And 11 times 2 is 22. And now if you look at it, it's just a simpler equation like we've dealt with. Now I have no fractions. I have a 4 being multiplied by x and a 1 being added. So I get rid of the addition by subtracting 1 from both sides. 1's cancel, equals 21. And then I divide by 4. Well, 21 divided by 4 is not a nice whole number, so we can leave our answer like that. All right, so let's look at another example. If you notice in this problem, the addition and subtraction that are a part of the problem is actually in the fraction. So before I can do anything with that minus 3, I have to get rid of the fraction. So that means I need to move the denominator. Well, that is 5 being divided. So to move that 5, I need to multiply. That means that the 5's cancel. 2x minus 3 equals 11 times 5 is 55. Now I have an equation that you should be used to seeing by now. To get the x by itself, we now move the 3 since it's subtracting. Bring down the 2x equals 58. Then we divide by 2. So then that gives us 29. All right, looking at the next problem, it looks very similar. It just has a negative 3x, but still it's inside that fraction, so I need to move the denominator. It's being divided, so we multiply. Those cancel, bring down what's in the numerator, what's up top, multiply 11 by 6. And then we have this, move the plus 3 by doing the opposite and subtracting. And then we divide by negative 3 because I want to move the negative as well. X equals negative 21. This was a 6. Okay. these are the another examples. Now, what's the difference between the problem on the left and let's erase this. Problem. Let's see here. All right, there, I got it. So this was the problem we did on the last page. What's the difference between this problem and this problem? Well, if you notice, I have a big fraction here on the previous problem. I have a big fraction here. I have a simple number to the right of the equals and a number to the right of the equals. So what's the difference? Well, notice that the big fraction has a number being added to it on the left, but over here there is no number being added or subtracted for that matter to it. So that means that before I can do anything with this problem, with this big fraction here, I can't get rid of the big fraction until I move this 7. So how would I do that? So first thing I'm going to do to move that 7 away from the big fraction so I can get rid of the big fraction is to subtract it since it's being added. It cancels out. I bring down my big fraction. And then negative 3 minus 7 is negative 10. So now, let me move this down some. I have just a big fraction, and I want to set equal to a negative 10. I want to get rid of the big fraction, so I multiply by 10 on both sides, because that's what the denominator was. Bring down what was up top, and negative 10 times 10 gives me negative 100. Now I need to move the 7. It's positive, so I subtract. And then I have negative x equals negative 107, but I don't want negative x, I want positive. So I divide by negative 1, because remember, any variable that doesn't have a number in front of it, it's like there's a 1 there. And then when I divide negative 1 on this side, it cancels, leaving me with x. Negative 107 divided by negative 1 is positive 107. So that's the answer to that problem. So now looking at the one that you were supposed to try, if I look, I see a big fraction that I know I'm going to have to get rid of, but it's not alone. There's a plus 7. So I need to move that plus 7 to the other side before I can get rid of the big fraction. It's plus, so I subtract it from both sides. So I bring down the minus 7 minus x over 3. The plus 7 and minus 7 cancel, and 8 minus 7 equals 1. Now I have just a big fraction to get rid of. To do so, I multiply by 3 on both sides. The 3's cancel. Bring down the negative 7 minus x. 1 times 3 is 3. And then notice this is what I want to isolate. So I need to move this negative 7. So to move the negative 7, it is negative. So I do the opposite, which is add. What you do to one side of the equals, you do to the other. Bring down the negative x equals 10. And so we're almost done, but again, we don't want a negative x. So remember, it's like there's a 1 there, so that's actually negative 1x. I need to divide both sides by negative 1 because the opposite of multiplication is division, and that will give us negative 10. So that is that problem. All right, and then next part says that we want to talk about is the different types of solutions for linear equations. Well, I have 3 different colored columns. There are 3 different types of solutions. There is what's called a single or one solution. There is no solution, and there are infinite solutions. So the question is, if I have divided these into these columns, and I'm telling you that this will give me one solution, this will give me no solutions, and this will give me infinite solutions, why am I telling you that? So let's work them out to actually figure out why. So let's move the y out of the way. down here. And let's look at the first problem where it says there is one solution. So if there's one solution, well, just for the equation, not because there's one solution, what would I do first to solve? Well, there's parentheses with stuff going on inside of it, so that means I need to use the distributive property. So negative 3 times 2x is negative 6x. Negative 3 times 4 is negative 12, so we put minus 12. Bring down to equal 14. And then I want to get the x by itself, so first thing I have to do is add 12. So I bring down the negative 6x. The 12's go away, equals 26. And then I have negative 6x equals 26. It's negative 6 times x. So to move that negative 6, I do the opposite of multiplication, which is division. That means that the 6's cancel. X equals 26 over negative 6. Okay? Which can be simplified. X equals 13 over negative 3. Now notice my answer. My answer is x equals negative 13 over 3. That is a number. X equals a number. So all these problems that we've been working with, our answers was x equals some number. Every one of them, x equals some number. And that number that x equals is called the solution. X equals, that's your answer or your solution. So solution is just another way of saying answer. So my answer, my one answer for this problem is x equals 13 over negative 3. Okay, so that's why there is one solution. And I also wanted to make note that this is called an identity. Okay. Actually, not here. This is called an identity, and I'll tell you why in a minute. This is just a solution. This problem here is just a solution. One solution. Okay. All right, so now the column in yellow, I've told you there are no solutions. Well, let's see what could occur if there are no solutions. So I have an equation. So I look at the left hand, there's an x. Look at the right hand, there's an x. So then I know I have to try to simplify both sides. Well, I look at the left hand side and I can't put anything together. So it's as simple as it gets at the moment. I look at the right hand side and I have parentheses. So that means I can do distribution. So I bring down what's on the left and I distribute the right. 2 times negative 5x is negative 10x. 2 times 2 is 4. Okay, so now I have an x on the left hand side and an x on the right hand side, and I need to solve this so that the x's are together. So remember, we're going to move the smallest x to the other side. Well, the x on the left is negative 10x. Right here. The x on the right is negative 10x, so they're the same, so it doesn't matter which one I move. So to move the negative 10x, I add it to both sides of the equation to its like term. So I bring down 7. The negative 10x and the positive 10x cancel. Bring down the equals. What happens on the right-hand side? The negative 10x and the positive 10x cancel. And I bring down the 4. There are no x's left in the problem. And this says 7 equals 4. Well, does 7 ever equal 4? No. 7 equals 7. 4 equals 4. So this is not a true statement. So that is why there is no solution, because this is not true. When you come to an equation and you simplify it, if you get a statement at the end that is not true, then there is no solution. All right, and then the last one, which is your identity, is called infinite solutions. And let's look as to why there's infinite solutions. So left-hand side is 2x minus 4. I can't put anything together or simplify. But the right-hand side, there's parentheses that I can distribute. So I bring down the 2x minus 4 equals. Now there's a negative out here. Remember, that's like a negative 1. So I'm going to distribute that negative 1. So negative 1 times negative 2 is positive 2x. Negative 1 times positive 4 is negative 4, so we subtract 4. Okay, then I go to move my smallest variable to the other side to the other variable. Well, they're both variables are 2x, so it doesn't matter which one I move. So I am going to subtract 2x on both sides. Well, the 2x minus 2x cancels. It's mighty light, isn't it? Bring down that negative 4 equals, well, 2x minus 2x cancels again, bring down the negative 4. Well, this time, what happens to my answer? It says negative 4 equals negative 4. Well, is that true? Yes, negative 4 does equal negative 4. That is a true statement. So when you have an equation that simplifies and has the same thing on the left as on the right, then you have what's called an identity. Okay, that means they're the same. Like you have your identity. You and your identity are the same. The left side equals the right-hand side. And when you have an identity, that means that there are infinite solutions. And we'll talk in more detail about what it means to have infinite solutions. But basically it means that the left-hand side of your equation is exactly the same as the right hand. And any number that you plug in for x will work on both the left-hand side and the right-hand side to make them equal. All right, and so then there's three equations, and I want you to match which one is the one solution, solve, match it, which one's the no solution, and which one's the infinite. So really quick, and notice I made it more complicated just to serve as some review. So if I look at the left-hand side, I have some like terms that I can put together. So a positive 10 and a positive 1 are 11. Bring down the minus 5x equals. On the right-hand side, I have two x terms that are similar. So positive 7 and negative 12 will give me negative 5x plus 11. Okay, then I want to move the smallest variable to the other side. Well, both of them are negative 5, so it doesn't matter which one I move. So since it's negative 5, I'm going to add 5x to both sides. Bring down the 11. Negative 5 and positive 5 cancel, equals. Negative 5 and positive 5 cancel, bring down the 11. Well, I have 11 equals 11. So we know that that is infinite solutions. Okay, so that went to there. Okay, next problem. Left-hand side, I have a positive 12x and a positive x, which gives me 13x, and bring down that negative 3 equals. I have a positive 5 and a positive 8, which gives me 13x, bring down the minus 4. So I want to move the smallest variable to the other side. Well, I have positive 13 on both sides, so it doesn't matter which one I move. So I'm going to subtract 13x from both sides. 13 minus 13 cancels, bring down the negative 3. 13 minus 13 cancels, bring down the negative 4. Well, now I'm left with negative 3 equals negative 4. Is that ever true? No. So the answer to this is no solution. So that means that the answer to this problem is no solution, which means then that this, by default, should be one solution, but let's test it to be sure. Well, looking at the left-hand side, I have parentheses, and that's like a 1 there, isn't it? So I need to distribute. So I bring down the 5, and I say negative 1 times n is negative n. Negative 1 times negative 4 is positive 4, so we put it down as plus, equals, and there's distribution here as well. 3 times n is 3n. 3 times 2 is 6. Now I look at the left-hand side, and I have a positive 5 and a positive 4 that can be put together, so it gives me 9. Bring down the minus n, equals 3n plus 6. And now I want to simplify this, so I move the smallest variable to the other side. Well, I have negative n, so it's the smallest, So I add it to both sides since addition is the opposite of subtraction. Bring down the 9. Negative n and positive n cancel. Equals 3n plus n is 4n. Bring down to plus 6. Now I need to get the n by itself, so I need to move the 6 by subtracting. So 3 equals 4n. Divide by 4. N equals 3/4. One number, which is how we know that there is only one solution. So this is one solution, and that solution is 3/4.